Okay, so for 104C, you're going to have to give me the information that we've already learned in 104. So 104 is the DDT question, and what was the limiting reactant that we found? Okay, so if that's the limiting reactant, C2HOCl3, and the question is what mass of excess reactant is left over? So the excess reactant was the chlorobenzene, the C6H5Cl. So we have the excess reagent was the C6H5Cl. And how much did we start with the excess? How much were we given in the problem for the excess reactant? What was he given? Yep, Nick.
1,142 grams.
Okay, so we started off with 1,142 grams of the excess reactant, and we didn't need it all, okay? So this was the limiting reactant. So I'm just going to write the equation back out here. Okay, so this is what we found to be the limiting reactant, and the question is, how much of this is left over, right? So how would we go about finding that? What we're going to do is we're going to figure out, based on this given amount of the limiting reactant, right, so this is the limiting, we're going to figure out how much of this would we need. Never mind the fact that we knew how much we were given. We're going to figure out how much we need. So we're going to do a stoichiometry problem. How many start with 485 grams of the C2HOCl3, and we're going to ask how many grams of the C6H5Cl did we need? Forget that we know how much we had. We have extra. It's like the ham sandwich. I have 24 slices of bread and 10 slices of ham. How many slices of ham do I need? Right? Or how many slices of bread do I need because the ham is limiting? I need 20 slices of bread. If I find out I need 20 slices of bread and I had 24, how much is excess? 4. So you have to figure out how much you need and then compare it to what you started with. So my first step is to get to moles. So what's the molar mass? So there's your stoichiometry equation. So you're going to do 485 grams, and then you're going to get it into moles, and then you're going to use the mole ratio to get the new moles, and then you're going to use the molar mass. So grams of C2HOCl3 go away, moles of C2H2Cl3 go away, moles of C6H5Cl go away, and we end up with grams. So what do you get for the number of grams here? Megan, what'd you get? 401? So actually this is 741. Okay, so that's how many grams you needed. How many did we start with?
1,142.
Yeah, we started with 1,142. So if we started with 1,142 grams and we only needed 741 grams, then that means I have this many grams excess of C6H5Cl, right? And when you do that subtraction, you get 401. Let's put the molar masses up. Go ahead, yep.
Ag2O is 231.74 grams.
Okay, so Ag2O is how many?
231.74.
231.74 grams. We're just going to get the molar mass of them, okay? And then what's the molar mass of this guy here?
250.31 grams.
250.31. All right, and what about this one here?
Is 357.17.
357.17 grams, and we know water is 18.02 grams. All right, sometimes if I know I'm going to have to use them, I'll get the molar masses early, but don't waste time getting molar masses unless you know you need them. So, how many grams of Ag2O are we starting with? 25 grams of this, right? So we have 25 grams of this, and it's 25.0, and it's reacted with 50 grams of this. And the question is, what mass of this can I make? This burn treatment cream. This is a real cream. Oh, hard to see that, huh? Too hard. And we're going to start off with Ag2O. So we're going to say we're starting with 25 grams of Ag2O. And we want to figure out how many grams of this burn cream we're trying to get to. And I'm going to abbreviate it as X, okay? This We're just going to call this X for right now, just because I can't fit it on this screen. All right, what's the molar mass of this? We need to get to moles, so we said the molar mass is 231.74. So 1 mole of Ag2O is equal to 231.74 grams of Ag2O. What's the mole ratio in our chemical reaction? 2 to 1, right? So we're going to do 2 moles of X for every 1 mole of Ag2O. Okay, and I'm only using X because I can't fit it on this screen. And then we're going to do the molar mass of X. So we're going to say that we know there's 357.17 grams of X. 1 mole of X. Moles of X cancels. Okay. Because you're given the amounts of 2 different reactants, it's a limiting reagent problem, so you have to test the other one. So we're going to say, all right, well, we were given 50 grams of the C10H10N4, oh, that's another long one, H10N4SO2, and we want to get rid of grams of that into moles. So 1 mole of this stuff over 250.31 of this stuff, okay? And then we're going to do the mole ratio, which is a 2 to 2. So our mole ratio is going to be 2 moles of X over 2 moles of this stuff, which I'm sorry, but I'll call this Y. I'll call this Y. And then from there, we're going to do the grams again, 357.17 grams of X for every 1 mole of X. And what do you get? So how many do you make with this one? 71.3 something, so 71.4 grams. 71.36, so 71.4 grams. Okay, so we're done with that one, 71.4 grams. So we'll go on to the next slide. We have this iron ore sample. So this is like, you know, a hunk of rock, basically. And in this hunk of rock, there is some of this hunk of rock is iron oxide, but we don't know how much, right? So the overall rock, and this is why I encourage you to try to draw a picture. The overall rock is 752 grams. And we put that rock with some carbon, and we end up making iron and CO. All right, so it says that an iron ore sample contains iron oxide plus other impurities. So there's other things in this rock that's not the iron oxide. When it's heated with excess carbon, it produces 453 grams of pure iron. So this is what's given. We're given that number. What is the mass percent of iron oxide in the impure iron sample? So the question is, what is the mass percent in this hunk of rock that's iron oxide? So how would I answer that question? Never mind the stoichiometry. So on this one, we need to figure out what portion of the 752 is iron oxide, and then we're going to take that, the mass of iron oxide that we find, and we're going to divide it by the 752 grams and times 100, and that's going to give us our percent of this rock that's iron oxide, the mass percent. So in order to do that, the real question is find the mass of iron oxide, and the way we find that is from the stoichiometry. So we're going to start with 453 grams of iron is produced. What is the molar mass of iron?
55.85.
Okay, so now we're in moles of iron. What's the mole ratio I need to put in there next? 2 to 1, right? So we're looking at, we have 2 moles of iron here for every 1 mole of iron oxide. So we want 2 moles of iron. We want moles of iron to cancel, 1 mole of iron oxide. We're trying to find the moles of the grams of iron oxide. That's Fe2O3. And what is the molar mass of iron oxide so that we can get to grams of iron oxide so we can plug it into our formula up above. Molar mass of iron oxide. 159.75 grams of iron oxide. So I need a better stylus. It's falling apart. And 1 mole of iron oxide. cancels. So how many grams of iron oxide would you make? 648 grams. And that's the portion that's blue in this rock. It's 648 grams of this 752. So 648 over 752 times 100. And that's going to give you the mass percent that's in this rock. And it comes out to be 86.2% of the rock is iron oxide.